Hello, my name is Molly Nichols, and today I'm going to be talking about analyzing theophylline and cocoa powder effects on glycogen phosphorylase. Glycogen phosphorylase is an enzyme used in the breakdown of glycogen. This enzyme has two different forms, an active and an inactive form. For this specific experiment, I'm going to be focusing on the inactive form, which is glycogen phosphorylase B. Glycogen phosphorylase B stimulates the release of a phosphate group from glucose 1 phosphate. Glucose 1 phosphate helps regulate liver and muscle glycogen concentrations and is used in many metabolic pathways in the formation of energy. An example of this would be in glycolysis for the production of ATP. The mechanism being studied in the experiment can be seen in the first figure of the background section. Below this figure are two chemical structures of caffeine and theophylline. These are key components in the reactions taking place later on. The first step in this experiment was to generate a standard curve for inorganic phosphate. This first graph in the results section shows that standard curve. This plot can be used later on in calculations for determining the activity of glycogen phosphorylase B. The second plot in the results section is the enzyme-free assay. This takes the concentration of glucose 1 phosphate versus the concentration of inorganic phosphate. This graph was generated in order to determine if there was any breakdown of substrate, and there was. So the data from this graph can be used later on in calculations for corrected values of glycogen phosphorylase B activity. Once those first two graphs were generated, it was time to test the three effectors chosen. This third plot in the results section is the AMP assay Michaelis-Menten plot. AMP was tested at concentrations of 0, 0.5, 1, 2, and 4 millimolar. As concentration of AMP increased, the enzymatic activity also increased, as shown on this graph. This is a proportional relationship that indicates AMP is an activator of glycogen phosphorylase B. The same can be said for the second effector, theophylline. In this fourth graph of the results section, you can see the theophylline assays. Theophylline was tested at concentrations of 0, 1, 2, and 4 millimolar. And again, as theophylline concentration increased, the enzymatic activity also increased, indicating that theophylline is an activator of glycogen phosphorylase B. The last effector chosen to be tested was cocoa powder. These last two plots in the results section show the results from those tests. Cocoa powder was tested at concentrations of 1, 2, 4, and 5 millimolar. And as seen on these graphs, as concentration of cocoa powder increases, the glycogen phosphorylase B activity decreases. This is not a proportional relationship and indicates that cocoa powder is an inhibitor of glycogen phosphorylase B. This is due to the caffeine in the chemical structure of cocoa powder. The caffeine binds glycogen phosphorylase B, making it difficult or unable to bind the substrate and inhibiting the activity. Future studies of the enzyme could show how these specific compounds inhibit or activate the enzyme, whether it be directly or allosterically, and it can also give more insight into the mechanisms being used in these reactions. I would like to give a special thanks to my laboratory director and my laboratory instructor, as well as my laboratory assistant and my laboratory partner. I thank you all for your time today.